Another production tool, something that is going to make our work more productive, is the iterative execution of algorithms. This is what we are going to see next. And imagine that you have this layer, which is what I'm going to. You have this layer with polygons, right? And I'm going to try to cut the raster layer, but for each polygon, right? I want to just take one of these polygons and cut the raster layer just for this polygon. I'm going to show you how to do that. It's not difficult. But if I want to do that for every single polygon, and I have 10 or 100 polygons in my layer, that's going to take time, right? There's a tool, there's a way of executing an algorithm in processing that can automate that. Instead of saying like, I run this algorithm on the whole layer with n polygons, I run it n times with n different layers, each one with a single polygon, right? So I can automate that. And that's a way of also getting more productive. All these three things, the important thing is to know that they're not separate. That means that I can create a model and then I can execute the model iteratively. Or I can create a model and execute the model as a batch process. Okay, for instance, we have, I don't have my model in here, but we have created a model that computes the TWI from the detail elevation model, right? Imagine that I have 100 detail elevation model files. How do I calculate 100 topographic indices? I can go to the batch processing interface and run my model in a batch process, right? So that doesn't mean that we cannot combine them, right? By combining all these different modes of executing algorithms and of using an algorithm, I can get very productive. Imagine that you have to do this for 100 layers and it's 3 algorithms, like calculating slope, catchment area, then topographic wetness index. One and again and again and again. But I first put all these 3 steps in just one step. I already did that. I have my model. Now I put that and now I put that in a batch process and I run it with a set of layers just in one single step, right? Which is actually what we're going to do. We're going to cut this layer in one layer for each one of the polygons. Then I'm going to get a set of raster layers and I'm going to calculate a topographic wetness index for each one of these pieces, right? This is what I'm going to separate, right? You get the idea, more or less? So we're going to be more productive. Okay, the first thing we're going to try to cut this. So what I'm going to show you now is just how to cut a raster layer using a vector layer, right? This has nothing to do with models, with iterative execution, with batch processing. It's just another algorithm, and we're going to look for it. It's called clip grid with polygon. It's a saga algorithm. I mean, I could use other things, but I'm trying to just restrict my work to saga so it's easier. So I'm just going to take my my raster layer and my vector layer and pass them through that algorithm, use them to execute that algorithm that clips a grid with polygon. That's it. It cuts it like the cookie cutter that I mentioned the other days. We did something similar yesterday, but it was 2 raster layers, one of them with these no data values. Now I'm doing the same thing, but instead I have polygons. So it's like polygons and a raster layer, I cut it, right? Okay. So that's very simple actually. It's not a difficult algorithm. Right. It's pretty easy to understand the interface. We just have the input. It takes a raster layer and it takes a vector layer, right? Okay. For those of you that are arriving a little bit later, what we are trying to do is to cut now my raster layer, right? The original raster layer, cut it with the vector layer, just like cutting there. And later we're going to do an exercise about automating this process using this same technique, but instead of with the whole layer with all the polygons, doing it polygon by polygon, right? So that's it. Okay, so I just, have nothing else to select. The DM, the watershed in there. You just run it. And just get it. Use it. Actually, those areas in here that you see in white, they're not empty. We have the no data value, right? Actually, this algorithm tries to reduce the amount of no data values actually, so the extent is defined by the polygon, but all raster layers, they are rectangle. They don't have a shape like that, so I have to put something in those pixels and I use this no data value. QGIS doesn't render the no data values, so they are transparent. Right? But you see I have these values inside of the polygon, right? How can I do it if I want to create a cut, cut that raster layer, but using just one of the polygons? The most simple idea will be just to generate a new layer with one single polygon, right? Okay, there's another way of doing that, but I'm going to do it just that way. What I can do is simply I select the polygon. Remember, this is actually the polygon that we were using for the example in the other the example that we did yesterday. It was actually these. It was cut. So I just select that and I can save it. Save as. Oh, sorry, not that one. Save selection as. So I just save this selection that I have. Temporary file, wherever. One basin is going to be a shape file, actually. Let me put in here. It's going to be a shape file. Oh, well. So one basin dot shape file. Right. I'm just exporting that, and then I click Add Saved File to Map. Right. Easy. So I have my new layer in here. Right. And now I just do the same. Clip grid with a polygon. Now I enter my DM and my one basin, right? Okay, so I'm just cutting, but instead of using the whole layer, I use just one single polygon, right? Yep.
When we only select one polygon and do this clip, then it should work.
Yeah, it should use that. That's what I'm going to now. Yeah.
No, saving it.
Yeah. So the thing is, it's like this was like the obvious way, but I say like it's good that you remember that. If we have a selection, processing is only going to use a selection, so there's no need to export the layer, right? Should work. I don't know if it's going to work. See, yesterday we were having problems with the selection in some computers, but if I just now use that clip grid with polygon and I use my full watersheds, I just have one polygon selected. So let's see what it does. Yeah, it takes everything. So it seems that it's not aware of the selection for some reason. Yeah, it's the same problem that we were having yesterday. So in theory, it should do that, right? But it is not. So that's a reason for it. Okay. So, well, in any way, even if it worked the selection, I have to select clip, which is pretty boring thing, right? So we have to do that. I have 10 or 15 polygons. I don't know how many polygons, but I could have 100 or 1,000 or whatever. So I just want to do that cut. So I end up having like one polygon for each of this. So I get, sorry, is it that one? Yeah. Okay, let me get rid of the other ones. Right. So I just get one polygon for each of them. If I want to just get the extent of that, remember it doesn't get the full extent. I said that it actually restricts it to the extension. I can see to paint that, and you see that it's not the full extent. It's just the extent of the polygon, but there's still no data values, right? Okay. So how will you do that? Now there's no way you can do that automatically if with what we have already seen, right? You can do the modeler, but you can use the modeler to automate anything here. I could just split the layer into many layers, but I still don't see the way of doing that. So what we can do is just go to our normal algorithm. Let me take all that away. Right. Clip grid with polygon, and I do exactly the same. The DM and the watersheds, but instead of saying like, yeah, take these polygons and use that all the layer, right? If I click on this button in here, okay, iterate over this layer, what it's going to do is just turn this layer with 16 polygons into 16 layers with one polygon. And then it's going to run the algorithm 16 times, right? And then I'm going to get the output, right? The file name that you enter here, if you enter like my raster or whatever restricted raster is going to add numbers for that one, like 1, 2, 3, 4, and then so it's not going to use that number because it needs as many names as polygons are in the watershed. So it just takes the name as the prefix, and then it's add numbers. But I'm going to save it anyway to a temporary file, to a set of temporary files, right? But the way of using it is exactly the same. You just run it, but you say like, no, I want to do that, you know, separate my vector layer, split it into different vector layers with one single polygon, one single line or a point, whatever the geometry that you have in there, and then just run all that, right? And I'm going to get that. If you click on run, it's going to work, but it's going to fail a couple of times, and I'm going to explain you why. So that's one, I'm doing that on purpose so you understand what is going on actually. See if you can figure out what's going on actually. So I'm going to click on run, and you're going to see that it runs several times in there. You see it? It's running in here. Oh, it is. I didn't click the button. Actually, that's a good thing. Let me click on that so it's just like active. So you see it's executing iteration. Yeah, you can see it in there to show you. You know, it's doing the same thing, 1, 16, 2, 16, so you know, it's iterating over that. Now it's going to fail like 5, 6 times. You know that from these 16 files, there are 5 or 6 that it cannot create, right? I'm going to explain you why later, so that's a good idea.
I didn't get any mistakes.
You didn't get any mistakes?
Nope.
Don't know. You should.
Yeah.
You should actually. And okay, the thing is that, okay, you can see the result in there, right? It's really well done. You can. I see all the different parts, right? You see, I can just remove. I can remove the lower one actually, in there, and you see I get all the pieces of my block, right? It's just like cut into one for each polygon automatically. You see there are like the number of times we have been executing that 16 times, right? But if you count there are no 16 pieces, right? It's like 1, 2, 3, there are like 10. So we're missing 6. But I don't see where they're missing. Like this seems to be complete, right? There seems to be like all the polygons. If you go in there, no, it seems to have all the polygons actually. What's going on in here? Anyone can get an idea? Yeah.
Have some very, very small catchments.
There's some very, very small catchment. That's it. There are some catchment areas that only have 1 pixel. It's like a tiny square with 1 pixel or 2 pixels. When I call Saga and say like, cut this raster layer with this tiny polygon that is just 1 pixel, Saga cannot do it, right? So now what I invite you to do, let's see if you can do it, is just to try to filter out those polygons. So instead of having my watershed with 16 polygons, some of them so small that they're useless and are going to break along the way, let's see if you can filter out and clear that. Just like, let's work only with the good watersheds, okay? So I gave you 5 minutes, so see if you can try to find out how to do that, right? So what we can do is just go to the layer that we want to filter out. Let me take all that away. And we can actually edit directly if we don't want to use processing. So we just edit the layer in here. Click on the calculator, right? And we add a new field called area, right? With the geometry area, right? So that's it. I'm just creating a new field with the area of which geometry. There it is. It's, oh, yep, sorry. I just have a selection, so I have to remove the selection, put that into the area fill. That's it. Okay, so I get the area, and now I can just close this. You see, and there's some pixels. They just get 625. That is that's the area of 1 pixel, right? That's the area of a single pixel. So that's what I'm having, or I have the area of a couple of pixels with some variation depending on how it's measured. But you know, I have this very small ones, and then I start to have things that make sense, you know, right? Things that are a good bunch of pixels. But those first ones, I don't have them. So what I can just do is directly, grab them in here. I select those ones, well, I select actually the other ones. And, I think probably can delete them from here. Yep, they're gone. So I'm just having this first set of pixels, and that's much better, right? 8 basins, but it's what I really wanted to keep. 8 in my case. Maybe I did.
0.2.
Yeah, but it goes up to 7, right? I'm missing number 4. If you're counting on the ID, I'm just watching the column. This seems to be like 1, 2, 3, but there's missing a 4. Save. Okay, so now I have my layer, and now I can go back and do all that, right? Do you get the idea?
Yeah.
Right. Okay, how will you do that now? Another little exercise for you. How will you do that? Imagine that you have your layer and your DM, but do the same thing, but instead of the result, instead of being a set of 9 smaller layers with the DM, I want 9 smaller layers with the slope, right? But I want to do that in a single step. So it's not like I calculate the slope and then I cut it. How will you do that? Okay, think about it. How will you do that? Having the same idea, taking my DM, and in one single thing, getting that DM cut according to each polygon and have the slope of each one of those polygons. So there are 2 things that we have to do. One is to run the clip operation. So it takes the polygon and the layer and it actually clips it and cuts it. The other thing they have to do is to compute the slope, because I don't have the slope. I have the DM, right? So my user is going to give me the DM and the polygons, and I have to just create the slope and then chop it, clip it according to that, right? So I'm going to go to the modeler, because this is clearly a thing for the modeler, because I have a workflow. When I have more than one algorithm, it's a workflow, right? I'm going to go through 2 algorithms. One is the clip algorithm, the other one is the slope one. So I have 2 algorithms. That means that I have to create a model, right? So I'm going to ask my user for a DM, just like in the other models that we have been creating. A raster layer, DM. It's a required one, of course. If I don't provide any input, I'm not going to be able to calculate the slope, right? And now here is the thing, that I have to do the clipping and then the calculation of the slope, or I can do it the other way. First I calculate the slope and then I do the clipping. Which one do you think is best? Or if there's any difference? What is better? Is it better to compute the slope and then clip the slope layer, or to clip and then compute the slope? Clip and slope?
No, slope and clip.
Slope and clip?
Then you have the surroundings.
Slope and clip? It's actually better clip and slope, because if I do the clip, then I have less data to compute the slope, right? So if I do the slope, it's like I'm calculating the slope in places that I don't care about. So I'm wasting my computing power, right? So it's better to do the clipping, but actually you can compute. I mean, the slope can actually be computed even in the boundaries. Like there are additional formulas for the slope. So it's not going to put no data in there. But yeah, that might be true. That's good. A different point of view. I was just, focusing more on a processing point of view, like, the terms of speed. Okay, but that's a good point. Okay, anyway, just do that. So I just add my algorithms. I clip that. Sorry. I need to ask the user for the polygons. I forgot that. So it's a vector layer. Polygon. This is a type that we hadn't seen before, but it's defining a parameter anyway. It's polygons, right? It's required and it's polygons. So I get my output, then I clip, and then I do the slope, right? Then whatever. And instead of taking the DM, I take the clip one already. Okay. And I'm just outputting the slope. That's a slope, right? Right, I have this. I call it clip and slope. My models. How is this? Let's call my models. Up. Right. Have it there. Save it. Clip the slope. Up. Clip the slope. That's okay. And if I now go to my screen here, that's the clip and slope, right? So now I have something that I enter DM and the watersheds. That means that it's going to compute a new slope layer that just has slope values within the watersheds, like within all this together, right? I'm missing one because when I did the filtering, I filtered too much, and I removed one, but don't worry about that, right? So if I just run it normally like that, it's going to clip and then calculate slope. So I will have all slope values all along this the layer wherever there's a watershed polygon, right? But I don't want that. I want to have one different layer for each different polygon. So I just do the same as I did before with the just clip algorithm. Okay, this is clip and slope. It's not just clip, but it has the same parameters. A DM, a raster layer, actually, it doesn't even have to be a DM. Well, yeah, it has to be because I'm calculating the slope, sorry. But it's just basically raster layer and polygons. So it's exactly the same inputs that I had before. And whenever I have a vector layer, I have this green button with the circle in there. That means iterate, right? So I iterate over that. I can save them to actually slope.tiff. Right, that's it. Watersheds, DM. There are all the iterations. There I have all my slope pieces. And if I see the file names, you see they call slope 8, slope 7. You know, it takes the file name that I enter, slope.tiff, and it adds all this numbers. You know, it uses the file name as a prefix, but then it adds the names like slope 6, I guess. Slope 6, slope 5, etc. Right? And I have all these pieces that I can actually take away, right? So you can think about many different situations for this. You know, this is just one of them. But whenever you have something that you have a vector layer with several features and you would like to run that on every single feature for whatever you need to do, you just can run that, right? So you just do it and it will generate different vector. If you want to split a layer in different vector layers, you can do that or whatever, right? So it's pretty useful in this case of combining this raster and vector layers because I can just cut my raster in different rasters actually. No, just use one of that. So you get the idea, yeah. If I have a pixel, that, and I have all these values to calculate the slope on this value, I use all these ones, right? The 9 around. So if I just cut my layer in here, this pixel on the boundary, I just have 1, 2, 3 pixels they can use. The formula adapts itself. So if I just have 3, it will adapt to those 3, and it's gonna produce a value, but it's not the same value that I would have if I have this. So that's the thing that that's actually what you mentioned, the boundary effect. Yeah, good thing. So if I have different values in here, that might affect the value in here, or might not. But you know, it's good. Yeah. I was just thinking more in terms of how fast the processing it's actually. So it's much more efficient if you cut it before. If you want to make sure that doesn't happen, you can make your model a little bit more complicated. You just take the polygon, buffer it, cut, and then you just calculate the slope, and then you recut with the original one. You know, that's the good idea about the modeler and the main idea about the toolbox is that you have algorithms that are very simple. They do just most of the time, except for some of them, like in the Saga case that you have this algorithm for doing slope, aspect, etc. But the idea is to have algorithms that are very atomized, like very specific. They do just one single thing. If you need to do more than one, you just put them in the modeler and you create like 3 steps, 5, 100 steps, what you want. So it's just like very flexible thing. It's like a Lego. You take your pieces and you build with your Lego with that. So in that case, that thing that Martin says that is done with the LiDAR data, you can do it in here. Like you take your polygon, you enlarge your polygon, then it's fine. You can safely cut, and you can cut again. whatever. You can do like that, right?